Welcome back, everybody. Let's continue with our walkthrough learning CSS transforms. So this is what we are building, and this is going to be the last video in this playlist. So as you can see, we've worked our way from step 1 all the way to 80. So hopefully we'll do the last 24 steps. All right, so let's get started. So for step 81, what we want to do is want to position the foot element 85% from the top. So I'll give it a value of 85%. And then we also want to give all corners a border radius of 50. So we'll say border radius, and we'll give it a value of 50%. All right, now as you can see, the 50% value sort of round it up, making it look more realistic. On to the next step. So now what we want to do is for the pigeon's beak and feet, we can see that they are of the same color, so they are both orange, right? So what we want to do is want to create a new variable. Let's call this variable penguin picona, and I'll give it a value of orange. And then we'll place all the relevant property values with it. So let's go through the code. As you can see here on line 141 for the beak. So we'll place this. Let's save penguin picona. Okay, so I'm just going to copy this right here and then look for the other one. Where is it? Yeah, so for the foot, line 200. So I'll just replace this orange with the variable. Okay, there you have it. Now we want to target the foot element with a class of left. So we'll say .foot .left, and want to position it 20% to the left of its parent. Sorry, it's 25%. And then target the foot element with a class of right. So let's do that, foot .right. And then for the foot with a class of right, we want to position it 25% to the right of its parent, like so. All right, now we have our feet in position. Okay, so next up, what we want to do is we want to make the penguin's feet looks more penguiny. So by that, we want to rotate it a little bit, because when you look at the feet here, it's rotated slightly and it looks more realistic than what we currently have. Okay, so the way we're going to do that is to say, so we want to rotate the left foot by 80 degrees. So let's do transform. Let's give it a value of rotate, and let's say 80 degrees. And then let's do the same thing here. We'll say transform, rotate, and for this one, we'll give it a value of negative 80 degrees. All right, so as you can see, we have our penguin's feet nicely aligned. Now let's change the stacking order of the foot elements such that they appear beneath the penguin body. So as you can see here, the feet appears behind or beneath the body, right, and not in front of it. So the way we're going to do that is to use the Z index. And like I've been saying, when you use the Z index, the number with the least value or the element whose Z index value is lower will go at the back. So let's give it a value of -1. And as you can see, it goes behind the body element. All right, fun fact, penguins cannot fly without wings. Okay, so within the penguin body, before the foot element, which we have here, we want to add 2 divs. So let's add 2 more divs. and each of these div is going to have a class of arm. So for the first one, I want to give it a class of left. So I'll say left, and then I'll just copy the left arm div like so, and I'll change this one from left to right. Okay. Now let's target the arm elements and give them a width of 30% and a height of 60%. So we say dot arm, bring our curly braces. Let's say width of 30%, height of 60%. Let's also give it a background, which is going to be a linear gradient. We want it to have a direction of 90 degrees. So 90 degrees. And it will start at gray and then end at this RGB value here. So I'll just copy the color value and then paste it here. Okay, there you go. We have our first arm ready. So now let's create a custom CSS variable. We are going to call it penguin skin and set it to gray. Then replace all relevant property values with it. Okay, so let's say dash penguin dash skin. That's the name of the variable, and the value is going to be the color gray. So now what we are going to do is we have to scroll through, and wherever we have the value of gray, we can replace it with this variable. So let's see, where do we have gray? Okay, we have one here on line 65. So I'll just say var, use the var keyword, bring the brackets, and then I'll just paste the name of the variable there like so. Now let me just copy this and then look for the next one. So the next one is going to be, I think we have one on line 191. Yeah, the background color for the body. And then let's see if there's another one. Yeah, I think there's one on line 203. So let's replace this as well. All right. Now, let us target the arm element with a class of left. So we're going to say arm.left. And then we want to position it 35% from the top. We also want to position it 5% from the left of its parent. Then let's move on to the arm with a class of right. And for that one, we want to position it 0% from the top. Let us also position it 5% from the right of its parent. Okay, so this should be something is wrong. You should give the arm.right a right of -5%. Okay, -5%. Yeah, that works. So now we have our two arms here, but there's still some work that we need to do on it for it to look like what we currently have here. Okay. All right. So moving on, within the arm.left selector, we want to alter the origin of the transform function to be the top left corner of its parent. So to alter the origin of the transform function, we use a property called transform origin, transform-origin like so. And the value that we want to give it is want it to be at the top left. So we say top space and then left. Okay. Then let us keep the linear gradient on the correct side of the penguin's feet arm, left arm, sorry, on the penguin's left arm by rotating it by 130 degrees and then invert the x-axis. Okay, so first, what do we want to do? We want to rotate it by 130 degrees. So we'll say transform. Let's give it a value of rotate, and then the value is going to be 130 degrees. Okay, so this rotates our arm element by 130 degrees, our left arm element, of course. And then the next thing we want to do is we want to invert the x-axis. So we say scale, then let's bring the x, and then into bracket -1. Okay, so this invert it, so the lighter side of the arm is now at the top and the darker side of it is now below. All right, now let us rotate the right arm by 45 degrees counterclockwise. So let's say transform, rotate. So it's counterclockwise, so it should be -45 degrees. Okay, all right. Next up, we want to, what does it say? It's a fun fact: most, if not all, flippers are not naturally rectangles. Yeah, we have the arm or the flippers is rectangle. At least it looks nothing like this. So let's get to work on it. So what we want to do is we want to give the arm elements a top left, top right, and bottom right corners, a radius of 30 pixels. So basically we're going to use the border radius, and then the first three values is going to be 30%, because border radius work in a clockwise direction. So we start from top left. From top left we go to top right, from top right we go to bottom right, and then from bottom right we go to bottom left. So the way we're going to do that is say border radius, and then let's give it 30%, 30%, 30%, and then we'll give the bottom left 120%. Okay, so now our arms are looking more realistic. Okay, moving on, let's give the arm element stacking order such that they appear behind the penguin body. Once again, we are going to use z index for that. So let's give it a z index with a value of -1. Okay. Now you're going to use CSS animations to make the penguin wave. So when we look at this final penguin here, you see it's waving. Okay, every few seconds it waves. So that's what we are going to work on now. So the first thing we want to do is to define a keyframe. And to define a keyframe, what you have to do is to write the keyframes keyword, and then bring the name of the keyframe that you want to define, in this case wave, and then let's bring our curly braces. All right, now I want to give wave, which is the keyframe that we just created, want to give it 4 waypoints starting at 10% and then incrementing by 10%. Okay, so the first is going to be 10%, like so, and then I'll just copy it, paste it. Want to give it 4 of them, and we are told that each should be increasing by 10%. So from 10% we go to 20%, from 20% we go to 30%, from 30% we go to 40%, like so. Okay, now what we want to do is within the first waypoint, want to rotate to 110. Okay, so say transform, rotate 110 degrees, and then we also want to retain the scaling of the left arm. So let's do scale x -1, like so, because that's the current scaling of the left arm and we want to retain it. All right, now for the second waypoint, we want to rotate. So let's do transform and rotate by 130 degrees. And then we also want to retain the current scale of the left arm. So we say scale x -1 like so. Okay, so for step 99, want to, for the third and fourth waypoint, repeat the transform pattern that we have once more. So for the third one, I'll just copy this and repeat it here. And for the final one, I am going to copy this and just repeat it here, like so. Okay, so now we have our keyframe called wave defined here. Okay, so at 10%, we want this to rotate by 110 degrees to a hit 130 and then repeat again. So at the moment, we can see that the keyframe or the animation we've added is working, and that's because we've only defined it. We are not using it yet. So let's go on and see how we can use it. Okay, so now I want to use the animation on the left arm. The way we're going to do that is to have the animation last 3 seconds, infinitely iterate, and then have a linear timing function. So first things first, we need the name of the animation. So we see animation. The name of the animation is wave. Then what we need is the duration. So animation duration. And that is going to be 3 seconds. So 3s. Next up, we need a iteration. So we say animation iteration count. And that's going to be infinite. So we want it to continue forever, never stop waving. And then finally, we want a timing function. So we say animation timing function. That is going to be linear. Okay, yeah. So we can write it this way, or another way we can also write it is to just write this way. So wave 3s infinite and then linear. Okay, so the first value will be given to the animation name, the second value will be for the animation duration, the third value will be for the iteration count, and then the fourth value will be for the timing function. So you can do it this way too, and either way you will be still correct. All right, now let's target the penguin element when it is active. So we're going to use the active selector. So we say dot penguin dot active. Now active means when you click on it. So when you click on an element on the page, you've made it active. Okay, so when it is active, we want to increase its size by 50% in both directions. So let's say transform, and want to increase the size. So we are going to use scale. So we have scale, and then the value of the scale is we want to increase it by 50%. Okay, so normally the normal size is 1 or 100%. So if we want to increase it by 50%, then we have to use 1.5 or 150%. Either of them is correct. So let's say 1.5. Okay, now watch what happens when I click on it. You see it increases by in size by 50%. Okay, all right, so that's what the scaling does. Okay, let's go on. We are almost at the finish line. Let's continue. All right, so when you activate the penguin element, it might look as though you can drag it around. Okay, but this is not true. So we want to indicate it to users by giving the active element a cursor property of not allowed. Okay, so let's say cursor not allowed. Now watch what happens when I click on it. You see the mouse, we have this sign below the mouse. As you can see, that shows that this thing cannot be dragged. So when I try dragging it, it doesn't work. Okay. All right, so last but one, we want to change the penguin element transition behavior during transformation to have a duration of 1 second, a timing function of easing out, and a delay of 0 milliseconds. Okay, so we need to give it a transition property. The value is going to be transformed, and then we say 1 second for the duration, and we also want to give it easing out like so for the timing function, and then let's give it a 0 ms for the delay. Great. Okay, now finally, we want to calculate the height of the ground element to be the height of the viewport. So the viewport is the whole view from top to down. So we want to calculate the height of the ground to be the value of the viewport minus the height of the penguin. Okay, so we need a new value for this height. So we say height is equal to calc. We need our calc element, which will do the calculation for us, and we say 100 VH, which is the whole view height, which is 100 V8, minus the height of the penguin. So let's go and look for the height of the penguin. Should be somewhere here. Yeah, this is the penguin. Yeah, so this is the height. So that's 300 pixels. So I'll just copy it. Let's come back here. We say height for the ground is calc 100 VH minus 300 pixels. So whatever the value of 100 VH minus 300 pixel is, will be the value of the ground. Okay. All right, so that's it for this video, and also for this course as well. So we've done everything. We've worked our way through all of this. As you can see, we've done everything. So the only thing remaining now in this curriculum is the final certification project, which is a personal portfolio page. Okay, so this is the personal portfolio page. That's what I'm going to work on next. So if you love this video, be sure to leave a like and also subscribe to the channel, so that when I drop this video, you can also work through it with me. All right, so this is where we'll end this video. See you in the next one. Bye bye.